The warmer the air is, the more moisture it can hold, and that's how you feel real cozy and warm in your home.
The comfort factors in terms of the difference between heat pumps versus furnaces.
My favorite would be either a straight heat pump system or a dual fuel application.
Do you get that kind of feedback from customers that they think heat pump heat is less dry?
The reliability of those systems is pretty incredible.
I feel like when people are buying a home, they don't really care so much about the efficiency.
While they're investing thousands to make the home comfortable, they're also losing thousands on the value of the home.
When someone considering repairing versus replacing a system,
is this thing really operating at peak safety?
Hello and welcome to the HVAC Dope Show. Today we have a special guest for you, Dario Compain. He is a 3-decade veteran contractor. He's been doing HVAC on the East Coast. He has experience in everything from geothermal to heat pumps, inverter-driven heat pumps, high-efficiency systems, dual fuel systems. His company, IAQ Medics, also does plumbing. So he has a wealth of knowledge in the trades and how you can get the best HVAC for your home. Please help me in welcoming to the show, Dario Compain. Dario, thanks for being on the show.
Thank you. Thanks for having me visit. Appreciate it.
Absolutely. And so just the way I like to kind of start these things off is just to do kind of an introduction on your particular climate, some of your background, some of the systems you work on, and just tell us a little bit, about yourself. Just give us a high level overview about some of your expertise and what your background is.
Yeah, definitely. I guess I'll start with our market. So we are local to the DMV market, which is DC, Maryland, and Virginia. IAQ Medics in particular is located in Virginia. We've got a very unique market here weather-wise. We get the same humidity to temperature climate ratio as Miami, not for as long, but it gets very mucky here in the summer. And then in the wintertime, it gets very cold, very dry. It's not Green Bay cold, but it's cold enough. So what that gives us is a great bounty of different applications to work with. I mean, you named everything just a moment ago. I mean, boilers, forced air heat pump systems, you name it, we deal with it. So that's the overview of our marketplace there. Me personally, I've been doing HVAC for a little over 26 years now. Started very green, doing duct cleaning, helping out on installs, and then eventually made my way through service, becoming one of the power players at the company that I worked at. And I've only worked at two businesses. That's the previous company that I worked for, and then the IAQ that I started with my beautiful wife. So what we've done with our time here is really engaged with building the careers of technicians, giving them exposure to equipment that you wouldn't normally see. I mean, we have a philosophy that if it heats and cools, we'll work on it. So we've done everything from your normal residential applications to commercial applications to wine chillers insured for $4 million. So we'll do anything. Yeah.
Awesome. And then as far as just to give people some context, because I'm actually not that familiar with the market in terms of the temperatures, but what do you guys see in terms of temperatures there? Because you said, it gets cold, but is that like 20s? Do you get negative temperatures at all? Or is it mostly in the teens or?
Mostly in the teens and single digits. I mean, the 30-year average low for our region is 15 degrees. If you get a little bit further south in our market, it could be 17 degrees. You're talking about kind of an outdoor temperature with dips down into the single digits. Wind chills can take it a little cooler. Rarely we hit the negatives. From there, the dryness factor out there, of course, also affects how cold that cold feels, and it gets very dry out here. And then on the flip side, in the summer months, we'll hit temperatures averaging in the low to mid 90s during summer, with a lot of spiking up over 100 here and there. But the average temp, 95 degrees is our 30-year average high.
So yeah, it sounds honestly pretty similar to the Denver market. I don't think we have as much humidity as you guys do, but so it's pretty similar. What is your thoughts, just to kind of jump into it? If you had like a favorite system you put in a lot of, what's kind of your favorite system for the market? Do you do a lot of heat pumps? Do you do high efficiency furnaces, high efficiency heat pumps? What are you guys installing a lot of?
So to answer that, we do all of that, and we do a lot of all of that.
Okay.
My personal favorite, I'm a proponent of the electrification of the United States. So I do feel, particularly with inverter-driven heat pumps in today's world, that you can get very, very warm temperatures out of your vents, drastically different than the heat pumps of old, which is an efficient way to heat and cool your home. It reduces your fossil fuel footprint, your carbon footprint in the world. But for those people that do want to keep gas, or for me in my house, I'm off grid, I have propane here, I've got to think about efficiency and reducing that consumption. So having a dual fuel application is really a smart way to go. So it's still using a heat pump, which I'm a big fan of. And so I would say my favorite would be either a straight heat pump system or a dual fuel application.
And for customers that are looking to save money, does the heat pump, when does that make the most sense kind of in your region? Because you guys have a lot of oil systems out there too still in parts. Is that correct? Or
We do. And oil is becoming more and more scarce to find contractors to work on it. It's an older kind of technology to heat homes, really necessary in your more northern regions where it can get very, very cold and you need higher heat outputs. So for our area, converting from oil to a heat pump system is a smart idea. Now, to get the comparative nature of comfort, we would want to go with an inverter driven heat pump system. And that's a system that provides variable capacity. Its efficiency and the way that it operates, it pulls more heat out from outside. And like I said, it can actually provide close to gas furnace like temperatures coming out of your vents, which again, that's just so different than what heat pumps have been generally and what people are used to when it comes to heat pumps.
For sure. Yeah, I know a lot of, I mean, one of the things we talk about on our channel a lot is the myth of, heat pumps not working in cold climates. It's like, my heat pump will work and it gets down to -15 at our house sometimes when we'll get like a cold snap. And granted, we do have, a backup boiler, but it's the heat pump runs, it stays comfortable. And so I know things have definitely changed, and that's not so much the case. And as far as just touching again on savings, because you're talking about your carbon footprint, one of the things a lot of people ask about, and there is some truth to this when you really dive into it, is that if you just switch to a heat pump, but you're not cognizant of like where your electricity is coming from, there can actually be either, it can be a wash almost, because even though you're electrifying at your electrifying at your home, the source of heating, you're really just outsourcing your emissions to the plant. If it's like at a coal-fired plant or something like that, do you guys do or deal with systems? Are people putting in solar out there? Is it a good climate for solar, or what do people typically do?
Actually, yeah, DC and Maryland in particular have, government assistance or subsidies to get those systems in as well, or to put solar in particular. So you can put solar in, store it in a battery in home, and then utilize that to actually feed the energy to your heat pump system, car chargers, whatever you've got in the home.
Cool.
Yeah.
Right on. And then as far as it, like your opinion on that, because I know I've heard that said, but do you think that's there's some validity to that, or is it I mean, do you think that's just people that are maybe naysayers or don't? I mean, some people I talk to, they just like, they hate heat pumps no matter what you tell them, sort of thing, and they just like, no, just put in a good old gas furnace. It's like, that's fine, we'll put in what you want, no
Yeah,
worries.
yeah.
What's
I have found with heat pump systems that if you get people who have had heat pumps in their home before and they have the older kind, particularly using R22 regular Freon as we know it for the refrigerant, it's known to be very drafty. You're going to have lower temperatures coming out of the vents. It runs all the time. There's air constantly moving, so it's pulling heat off your body a lot faster. Those are typically the naysayers. Now, in terms of the validity to outsourcing your carbon footprint, I mean, in some areas that can be the case. Our area does have some coal-fired plants nearby that help to generate that, but we've also got some water plants as well. And the water plants are the ones where you're just using moving water to generate a lot of that electricity. So you're really not outsourcing at that point.
Cool. And then interesting question, kind of on that same note, and I don't know if you don't know the answer to that, that's fine, but we have something out here where on your bill you can actually specify the type of electricity, where you can actually say, hey, I'll pay an extra, I think it's like only like 1 or 2 cents a kilowatt hour, and you can actually buy green off the grid. So basically what that means is they have, for your consumption, they have to allocate a certain purchase from clean sources. Do they have something similar out there with some of the utilities, or?
Not in our region that's being
Okay.
advertised openly. No, not that I'm aware of.
Okay. I was just curious. Sorry, I know that's kind of out of left field, but figured
Yeah.
I figured I'd ask. So kind of segueing off of what you were talking about with heat pumps, you mentioned, sometimes like the older style heat pumps, people felt drafty in their house, or they're not getting the same temperature at the vents. One thing we've explained to customers is we've talked about how humidification can actually make you feel warmer because you have more moisture in the air. So and I know your company is called IAQ Medics, so I assume you do quite a bit of IAQ products. You guys do humidifiers out there, correct?
Yeah, we definitely get involved in humidifiers, all different applications.
Okay. And then as far as like steam versus bypass or powered, are you guys mostly sticking with steam, or what are you guys recommending?
I'll tell you that I definitely lean towards steam myself. I have a steam in my house. I talk about it with a lot of my clients. And for the larger cubic volume homes, it's really what's needed. And I find that a lot of my competitors tend to shy away because they're worried about the price point and how our public might actually perceive that price point. But really, what it boils down to is when you have a home that has significant square footage that could equate to a large number of cubic volume based on ceiling height, you're going to need to have a steam in there. Now, if we're talking about a row home or a townhome, that you could use an evaporative humidifier and be just fine with that, especially with some of the newer products that are available now where they're significantly reducing the water consumption on that. You can humidify pretty well. But steam has the ability to put up to 35 gallons a day directly into the air. And to your point, moisture retains heat. The warmer the air is, the more moisture it can hold. And that's how you feel real cozy and warm in your home, is by having a good working humidifier. And the steam is going to be the one that's going to outperform evaporative humidifiers 10 to 1 easily.
Cool. Right on. Yeah. No, we have kind of the same experience out here for people that are, serious about humidity, or especially if they have like wood floors, guitars, musical instruments. We get a lot of people with pianos that are like, can you get our humidity to 41.6? I learned that number from the piano people asking
Yep.
about that. And I was like, oh, I guess we can. But out here, we actually have to run it at about 35. Otherwise, you get moisture on the windows.
Yeah.
A lot of times. And so, well, in addition to steam humidifiers, are there a lot of other IAQ products that you guys are offering that you see customers like have demand for, like the UV products or anything that are air filters?
Yeah, air purifiers that utilize UV is a big one. That's something that we're deploying pretty much on every install that we're completing. And a lot of that boils down to, a lot of the equipment that we work with has the prime breeding grounds for bacterial growth and things like that. And so the best way to take care of it is using the world's best sanitizer, which is the sun, right? So we can contain that in these ultraviolet lights that can work with carbon grids to help reduce odors, as well as kill any microbes that would be found locally at the evaporator coil or within the air handling system. And that's a good way to keep the equipment clean, keep your air clean, keep everything fresh. And of course, I mentioned the odors. You can keep odors down. And so ultraviolet lights would be a very popular IAQ product in our region.
Right on. And as far as, I love the filter debate, we can always get into it with filters because people have asked me out here, we show up and we'll see the classic case of like the 1-inch Heimer filter. Someone throws it in and then it trips, on a furnace, it'll trip their system on high limit, or cause system icing in the summer. And they'll always ask me like, well, why do they sell these then? And I honestly don't know, because we don't get airflow, the best airflow out of them. We're at altitude, so it's a little different. Air is already thinner here, and I think that maybe makes it worse. But what's your opinion on some of like the higher MERV rated filters? Are you guys putting in like the 4-inch filter boxes or any of the high flow filters, or what do you recommend?
We do. Yeah. Firm believer in media filtration. I'm not a big believer in electronic air cleaning. As we know, with all the data that we have available to us, if you don't maintain those properly, which most homeowners are not giving it the time that it really needs, you're going to have a significant reduction in its effectiveness. So going with the non-electronic media filter is by far and away a good way to go. Now, the MERV scale, which measures filtration efficiency, tells us the MERV 16 being the highest level is going to provide the most efficiency. However, you can get MERV 16 filters that are non electronic, but you're going to have a significant restriction of airflow, like you just mentioned. So, one of the ways to avoid that is by using a MERV 13 filter. And that MERV 13 filter is going to allow for air to pass through it sufficiently so we don't have restrictions causing equipment to ice up, or limits to trip or anything like that. But it's also going to provide the capture and kill filtration technology. So there are viruses in the air to get trapped in that fabric and that material and be killed and then stored there until it's discarded. So it provides good airflow while providing a top level of filtration as well. And we put those on every system we install as well.
And the MERV 13, which you're talking about, the 1-inch, or you do a larger system?
Yeah, it's 4-inch wide.
Okay.
And we tend to lean more towards the April Air product. I hope it's okay to speak about OEMs.
Yeah, of course, yeah.
Yeah, April Air makes a fantastic MERV 13 cabinet. It's pretty much airtight with the way that their slide rail system works, and you just slide the accordion filter onto the rail system. it forces 99% of that air to pass through the filtration with very little leakage on the sides.
Right on. Yeah, no, we've done, static, pressure checks, with like it wasn't until I was kind of a couple years into HVAC that, because I always thought, the thicker filters would cause more restriction because it's a bigger filter. Why wouldn't it? But then when you realize that the surface area is massive and it's got those
Yeah.
deep pleats that,
Yeah.
and I hooked it up and I checked, I was like, the static pressure, I think, was like a 0.2 or something inches water column, which for reference for any homeowners watching, 0.5 is kind of your sweet spot or what you target. So anything below that means the system is breathing well and has not restrictions, and it's your equipment lasts longer that way too.
Yeah, it also surprises homeowners too when you tell them it's okay to leave that filter in for 6 months, because
Yeah.
part of what makes it more efficient is it getting a little bit dirtier. So it's a unique experience when you see them. They're a little like, oh wait, you just leave it in? Yeah, you leave it in. Don't worry, it's gonna be okay. There's a lot of surface media there to
Yeah.
capture that dust. So yeah.
Yeah, no, that's awesome. That's one of my I change mine once a year because we don't really use AC up here that much, so we definitely don't need it. And yeah, it works great. So cool. What would you say to a customer that's kind of on the fence on the heating versus, furnace debate? Like if they're in the market for system replacement and they're thinking, okay, do I get a heat pump? Do I get a furnace? What would be the considerations that you would talk someone through if they had questions and were trying to make a decision on what's going to make the most sense for them?
Yeah, that's a great question. So, I mean, look, it first starts with what's already in the house, if there's something there. If not, we've got free reign to discuss what's going to be the best solution for them based on how long they're planning on being in the house, what future, things do they want to do with the house, add an addition, something like that. But if we're talking just about retrofit, which is just replacing equipment that's pre-existing, first thing is to understand what's there and what would be the cost benefit of converting to something different. Going from a gas system to an all electric heat pump system is going to carry some cost with it. I mean, you have to modify ductwork to be able to adapt the new air handling unit in lieu of a furnace, but you've also got to update the electrical circuitry as well. And if you've got to go through finished areas, you're going to have some drywall that's going to need to be repaired after the fact, probably with some painting as well. If you're running through unfinished areas, hey, great, you've got an easy run, but you still got to pay for the copper wire and all that stuff. So there's costs associated with all of it. Sitting down, talking with clients about, what is your near-term goal? What's your long-term goal? Probably the best question I can ask is, how long are you planning on being in the house? If someone's not planning to have much longevity in the house, the investment may not be worth their while to go through a complete conversion like that. So let's talk as if you're my client and you've got a gas system in the house and you're considering an all-electric setup. However, you're only planning on being in the home for maybe 5 or 6 more years. I would encourage you to steer away from that. That investment cost is you're not gonna see a return on that investment in that 5 to 6 year period. What you could do though is deploy a dual fuel setup, which is, I talked about that earlier. I've got the same situation here in my house. You can still get the functionality of the heat pump system, but instead of electrical resistive heat being your backup, you would go back to your natural gas setup, or in my case, propane. The good thing about utilizing a dual fuel application, particularly with these higher efficiency inverter heat pumps that exist, is the reliance on that backup heat is negligible. I mean, it's almost never going to turn on. And so if you're trying to reduce your carbon footprint, but you don't want to have a huge upfront expense, you do a dual fuel application, go with a high efficiency furnace, something that's 96 or 97% efficient. So in the few times of its operational life that it actually does kick on, you're going to be super efficient with how it actually burns that gas. And so that would be some of the things that I would want to discuss with my client to really discern what's going to be the right choice for them.
Okay, cool. And then as far as, on that note, like the comfort factors in terms of the difference between heat pumps versus furnaces, do you feel like heat pumps are more comfortable, or furnaces, or which one kind of do you think is more of an upgrade from a comfort perspective?
Another great question. Very loaded as well. I could answer that a multitude of ways. Heat pumps have come a long way. They really, really have come a long way. I mean, the heat pumps of old that would just turn on at one fixed speed were very drafty and made people feel very uncomfortable, typically walking around with a hoodie or something on in the wintertime. But with where we're at now, technology wise, and with how effective the performance of these new heat pumps are, and I don't even want to call it new because they've been around for a while, But we're just at a different place now. Fortunately, technology has finally gotten into the HVAC space. And with what we're seeing, you can get 115 to 120 degree air coming out of your vents using an inverter driven heat pump. So the comparative between that and a gas furnace, where you're going to typically see 120 to 125 degree air coming out of the vents, is they're pretty much in line with each other. So I don't think you could really miss the mark. It's just, do you want to save money on gas, burn less gas? What is your gas cost? Like for me with propane is incredibly expensive.
Yeah, 100%.
You get up to, $4 a gallon. So you really want to cut that out. And for me, going dual fuel was a no-brainer. I did a Platinum 20 inverter-driven heat pump from American Standard with a 96% S-Series furnace that they offer. My efficiency is through the roof. I was able to drastically decrease my electric bill for the summer months with cooling. But then also with the wintertime, I've only had to have my propane tank filled once every 15 months, where the previous owner of the home was having it filled up 3 times a year.
Yeah.
So
Yeah,
I mean,
that's a huge savings. Yeah.
yeah.
Yeah, and it's probably what, $2,000 to fill up your tank, or $1,500. I mean, it's not
Yeah,
cheap.
roundabout. Yeah. So I
Yeah.
would avoid that as much as possible.
Yeah, definitely. No, that's, and as far as like one thing we've heard from customers out here, I don't know if you have the same experience, is that we've heat pump heat tends to not be as dry as a furnace, because the heat from the heat exchanger itself, is because it's so hot on the heat exchanger, it tends to dry out the air and increases like static electricity and things like that. Like when we got the humidifier at our house, my wife was like, how do we fix this? I was like, babe, we'll put in a humidifier. We'll do it this spring, relax. And because we had to put in ductwork and the whole nine. And she was like, oh my gosh, it's so nice not like shocking myself on the lights every time I try to turn on a light switch. But do you feel the same way, or do you get that kind of feedback from customers that they think heat pump heat is less dry?
It is less dry, definitely. Noticeably different. Unfortunately, though, in our market, because it does get so dry outside, even if you got a heat pump system, you should still deploy a humidifier, because it's just every time you open the door to enter or exit your home, the humidity is going to go flying out, and it's going to get drier in the home. So yeah.
Right.
Yeah.
Right on. You mentioned the American Standard 20 series, or the 20 seer system, the Platinum
Mhm.
line. Is that your favorite system, or what is your favorite system that you guys install a lot of that you really like?
That's my favorite system. So I have had 3 homes where I've put a Platinum 20 heat pump in working. 2 of the homes worked with high efficiency gas furnaces as well. The reliability of those systems is pretty incredible. I mean, the both. So I still have two of the systems that have been in place for about 5 years now with no problem. I just swap my filters. I rinse off my outdoor unit twice a year. And that's really about all that I've been needing to do. Of course, I do the normal checkups that my team would do, but I've had no problems, no nuisance issues, nothing big, nothing little. It's been great. My previous home, and I'm still in contact with that homeowner because I installed all this equipment there and we maintain it still. It's been in place there now for 18 years and still has had 0 issues at all. I mean, nothing. No capacitors needed, no contactors needed. Nothing has been needed on these systems because they're so reliable. And then there's the comfort aspect. They maintain temperature so precisely. So the unique thing about an American Standard inverter heat pump is that it has 750 speeds built into it. So it's giving you precise comfort on both a temperature and humidity level. You can set not only your temperature, but the humidity that you want to keep it at for the summer months as well. So it just provides such optimum, pure, precise comfort when it comes to its operational characteristics there. The other neat thing is that, especially in the summertime, it's generally going to run at about 25 to 30% of its total capacity. And I think that's why it's got the longevity and it's not having any issues. It's less wear and tear on the system. It's not working as hard to maintain comfort in the home. So it's pretty impressive, actually.
Right on. And because a lot of people, they will have that thought about, they don't want to buy a fancy system, because if it's fancy, it must break down a lot, right? Because we know it's like you go out and buy a, I don't know, like a fancy German car. It's not necessarily the most reliable, but it might go fast, but you don't want go fast in your house. You want reliable, right?
Yeah,
And
exactly.
so 18 years, that's pretty good. Do you have people that have concerns with the refrigerant phase out, like customers that are concerned with the new refrigerants? There's R32, R454B. They're both like quote unquote mildly flammable. If you watch the videos on it, like you literally have to hold a flame to it, and if you remove the flame, it won't continue igniting. Also, fun fact, I didn't even learn this until this happened, but I guess 410A is actually 30% R30 or 50% R32 already. So it's already part of that blend. Like, what would you say to a customer that's either on the fence and doesn't want the new refrigerant and wants 410A, or someone who says, hey, I only want the new stuff? What would you, what are you hearing from customers, or what are kind of the trade-offs?
Yeah, it's been a mixed bag. So yet another great question from you. What I've been able to ascertain thus far are newer buying public, so the younger homeowners, the people that are new to what it is to maintain a home and have to have these responsibilities of replacing HVAC or water heaters or whatever have you. They are new, and so they're experiencing this refrigerant change for the first time compared to my older clients who went through the phase out of R22 to 410. Those clients are used to it. They already went through it once or at some point, and they understand that there's different types of refrigerants. The newer ones definitely have shown a concern for the flammability aspect of things, but education will supersede that fear. And so being able to talk with them about it, and to your point, 410A is 50% of R32, and ironically, 60% of 454 is R32. So all this blend is already existing. There's already refrigerants in use that are flammable, more so flammable than what we're going to be dealing with. And those are refrigerants you'll find in a refrigerator. People oftentimes just don't know. And if you can tell them why and explain to them the safety aspects of things, you can really tamp down their fears and get them to understand that it's going to be okay. We're going to be all right. Not to mention that there is technology that's being utilized in these newer systems that have a mitigation system built into it. So in the event that there's any kind of a refrigerant leak, there are sensors that are going to detect this and immediately shut down the system and turn on the fan to get the air mixing, because what we know about these mixtures, these chemical mixtures that make up these refrigerants, they dilute quickly. And so if we can blend it with a lot of other air, then its flammability reduces to almost nothing. So I'm not concerned. I've been in HVAC a long time. I feel like our industry is really taking this seriously, and they're putting a lot of education out there for the buying public, technicians, business owners. The OEMs are doing a really great job of letting us know what's going on out there in the field and what they're seeing in their test labs. So if there's anything I could say to the public, don't worry, don't fear it. It's going to be a benefit. It's helping with global warming. It's going to be an efficient refrigerant. It's still going to operate the same way that you've experienced. So just trust in our industry, and we're going to take care of you.
Yeah, no, it's an interesting point you mentioned about the refrigerators too, because I think I was looking at my label the other day, just like stumbled on it out of curiosity. And I don't some of them have like butane in them, or like
Yeah.
yeah.
Which
Yeah.
butane is what's found in lighters for anybody who has a lighter. So
yeah, and that's highly flammable. That's not like R32. That's because overseas, one of the refrigerants we get asked about a lot is R290, because one of the products that I'm looking forward to is the air to water stuff coming here. It's not here yet, but that's propane. But that's all contained outside. So even then it's kind of a non-issue. But no, interesting stuff. I always like getting people's opinions. In the DMV, it's always hard calling it that, because I think of the Department of Motor Vehicles, just being
right.
I'm a West Coaster. But but like in the DMV, I just picture like a grumpy lady behind the counter, like about to yell at me because I didn't bring the right form. That's my experience with the DMV. But no, but seriously, in the DMV, like in Denver, we run into, I mentioned altitude is something that we deal with a lot. So like if we're installing the system at 5,000 feet, you have to, put in certain pressure switches. If it's at 8,000 feet, we put in other pressure switches. We also, a 7-inch duct at 8,000 feet is going to be like a 6-inch duct at 5,000 feet. There's a lot of things that go into design considerations. What's the biggest mistakes that you see made on system installations in your region? And is it, airflow issues? Is it sizing issues? Is it not following best practices? I guess kind of walk me through what you guys see out there and what, homeowners should be aware of.
Yeah, it's a little bit of all of that. And so one of the biggest problems that we probably find are system sizing issues. And that's when clients have either had additions put in and it's not calculated in, or if it's an older home and it was predating, a formal manual J load calculation being completed, that's when they can get into some issues, especially with a lot of these higher end systems that operate way differently. You could end up having ductwork that's sweating everywhere just because the system's either too big for it or it's running too long at much colder temperatures and causing dew point to hit on the ductwork itself. So one of the things that we've got to actually mitigate that is a proprietary software that we use that actually captures, it scans a home using LiDAR, and it can capture a 3D image of the home. It automatically sizes out everything, and then we can put in parameters, what the elevation materials are, the windows, what their U value is, our value in the walls. We can punch in a bunch of parameters. And for a manual J that used to take a day or two to complete, we can now complete that in about 15 or 20 minutes. It's accurate, it's ACA certified, so it can be used for municipal permitting, which we've actually utilized it for. And it just saves us a headache of putting in the wrong size system.
And you're scanning that with an iPad or how is it, like a separate device, or how do you guys
yeah, it's using an iPad Pro. The
Cool.
camera on that iPad has the ability to use LiDAR, and so it scans everything. It's pretty neat when you're scanning the walls. You can actually see everything getting lined out, and then it's building a 3D image at the same time. It's even got a module where if a client wanted a ductless Mitsubishi system or something like that, we can actually put it on the wall and it'll show what its air distribution will look like in that space as well. So it's pretty neat. Yeah, it's very intuitive. And it's a great lifesaver for our client and for us. We trust the program, and when we're using it, we know that what we're doing is going to be accurate. And then we can easily set up our airflow profiles to accommodate the home and provide that client with long-lasting comfort that's not going to give them any issues.
Awesome. No, that's great. And then do you guys struggle with any of the same airflow issues? Like, do you have poor ductwork? Do you guys have a lot of flex duct out there? Do you have mostly hard pipe, or what are you guys running into?
Yeah, newer construction is going to have a lot of flex duct on the upper systems. If flex duct is going to be if there's going to be any ductwork it's concealed, it can't actually be flex duct in our region here.
Okay.
So we'll find flex duct up in people's attics. What we do come across more so over, though, is we live in an older area, so DC proper and the surrounding areas like Arlington, Alexandria. These were areas where we had ducted heating systems but no air conditioning. And so some of the big problems that I see that contractors do, especially if they don't have the experience, they'll go in, they'll say, "Oh, you've got ductwork. We can just install an air conditioning on top of the furnace." And then they end up with a lot of issues. They end up with a coil freezing up, water getting into the furnace, shorting out the circuit boards and some of the safeties in there, causing heat exchangers to prematurely rust and crack. And that's because that ductwork was not set up for cooling. It was only set up for heating. And go ahead.
Yeah.
Sorry.
No, you're good. And are you replacing the ductwork, or do you see like a lot of systems in attics or finished basements, or what are you guys running into as far as like install considerations?
Yeah, when we come across those kinds of situations, we definitely talk to our clients about a duct overhaul, because generally speaking, not generally speaking, you have to size the system to the ductwork to the larger load. And air conditioning in our region is always going to have a larger load than the heating. It's just inevitable. So we have to modify that ductwork one way or another. Now, if it's traveling through a lot of finished space and the client is not really ready for all of that upheaval, we can do one of two things. We can either modify locally and add more ductwork or more ducting to the basement area where it's still kind of unfinished and we can get to a lot of walls and really balance that comfort out. Or at that point, we could deploy a Mitsubishi system, go ductless and kind of attack it from that angle.
Nice. So you guys install a lot of ductless in your region as well. People like those.
We do. Yeah. DC in particular, there's a lot. Most of DC does not have air conditioning in the row homes. And
wow.
Yeah, it's wild. It's kind of weird to think, but it's all plaster walls. You've got about a 1.5-inch gap between the plaster and the actual cinder block that's joining them with their neighbor. It's not like you can easily run ductwork everywhere. And it's also DC, so square footage matters. And people don't want to run a bunch of ductwork where they're going to lose precious square footage, because it could end up being, while they're investing thousands to make the home comfortable, they're also losing thousands on the value of the home. So that's where you can utilize a Mitsubishi system. You keep your floor space. You put the wall units up, or the floor mount units that actually don't mount to the floor. They just mount to the wall really low. And their performance, their performance hounds, those guys will cool and heat super, super effectively. So,
and yeah. Do you get much requests for like installation of cassettes, or do the ceilings not really allow them out there? Or
there are some that do, and there are some that don't. So the wider row homes, the joist spaces upstairs will allow for that. For the smaller ones, it's unique that Mitsubishi came up with a one-way cassette. So
yeah. The
Most
14
frames are,
inches, right? They're like
yeah,
they're very narrow.
they're very narrow. Unlike a regular cassette that most people are used to, that's going to distribute air in four directions. The one-way cassette fits into a much narrower space. You can get it into a 14.5-inch wide space. They've even got a smaller unit that can fit even skinnier spaces now. But it's only going to shoot the air in one direction. Now you can control the swing on it, and you can get up there and control the sway, but you're not going to have four definitive directions of air distribution. But it's still very effective. Very, very effective.
Yeah, especially for cooling, if that's like in the ceiling on the top floor. I mean, you're hitting the heat where it's cooling the most. So that's I don't worry so much about the direction in that instance. Maybe for heating, I could see where four-way would be more important, but no, that's interesting. Kind of switching gears. So most of the people that watch our channel, a lot of them are in the market for replacement, and they take that kind of, the consensus seems to be a lot of people kind of, they find our channel and then they take their time, and they might be watching our channel for 6 months or a year while they're making their purchase decision. But other people stumble upon us because they're in a position where their system just went out, and so they need to make a decision, and they need to make a decision quickly. And so they're like, well, let me Google it before I just like sign on the system and see what's out there. And sometimes it's, if you go down those rabbit holes, there can be more options to choose from than what to do with afterwards. When someone's considering repairing versus replacing a system, right, which is a question we get asked about a lot too. What are some of the considerations you talk about with them? When do you recommend repairing a system versus replacement? Is it like a dollar amount threshold? Is it certain repairs? I mean, what are you running into kind of in the DC DMV area?
Yeah. So when it does come to that, how do you discern whether it's time to just go with the repair that's been presented or actually go with the replacement? I mean, there's a bunch of different ways to look at it. And let's start with what is the actual repair itself. So similar to a car, when it comes to a major component, such as a coil, particularly a condenser coil or a compressor, those are very intrusive repairs. It's very hard on the outdoor unit to go through a swap out like that. Imagine it to replacing a transmission in a car. That's what I would compare a compressor to. It's the heart of the system. And, taking it out, putting it in, there's just a lot of things that have to go on with it. And while you will have a warranty on that repair per se, it may not hold. It may not take hold a year later. And those repairs can be very, very costly. I've seen compressor repairs cost as much as $5,000 and $6,000, depending on what kind of compressor it is. So that's one of the things where it's, how intrusive is the repair going to actually be? So I've always commented to my clients, if it's a refrigerant related repair, that's something where you really want to consider the cost and what's going to be the value add there, especially if you're having any time in the home. If you're going to be in the home for another 5, 6, 7 years, you would be more inclined, it would be better for you to go with the replacement at that point, because it's going to be a very costly, very intrusive repair, and it may not last for you. And then the inevitable happens after you've already spent all that money on that repair. Now, if someone's faced with a situation where they're having some electrical failures, circuit board and blower motor fail, it can still be very expensive, especially with the variable speed motors that are deployed in today's equipment. It can get expensive. I mean, you could still be at about a $3,000 price tag for a repair like that. That's where you want to consider, how old is the equipment and how long am I planning on being in the house? If the equipment has some age to it, past 10 years, you should definitely consider going ahead and doing the replacement, especially if you're planning on being in the home for 3 to 5 years or more. Now, if you have a quick turnaround, if you're looking to be out of the house in 6 months to a year, you could comfortably go with the repair and feel okay about it, knowing that you took care of the problem, the system's going to work, and you'll be able to pass the baton to the new homeowner without much fear of traumatic failure right after the fact. If the system is 15 years old, I would still recommend replacing it then at that point, because it's too old, it's too old. So,
well, and it's not like a dollar for dollar thing, but doesn't it also make the home easier to sell, because it's not like, especially in a tight market, I mean, I don't know how much you follow the house. This isn't a housing market video, but I think, inventory in certain regions has been piling up. I know Florida has like a ton of inventory, that because everyone that moved there in 20 through 2022 is that now moving back to California and New York. And so there's a lot of inventory. And so like if you have a brand new system, that's something that the new homeowner doesn't have to worry about, right? So it's still like an added value.
It's definitely a value add. And the great point on the real estate side of things, we do need to know what's going on real estate wise. We're primarily a residential company, and so knowing what's going on in our housing market is a good thing. the DMV is a very transient area. It's politically driven, obviously. There's
Yeah.
also a lot of military around here. So generally speaking, there's roughly an 18 to 20% population changeover that's going to happen about every 2 years or so.
Oh,
Even
wow. That's a
more
lot.
population, yeah, and even more population changeover during the presidential cycle, because that's when you're going to have more administrations leaving, more of the military leaving, and then more of an influx coming in. At that point, definitely a value add to have a new system with a clean warranty in place. That's the homes that we see selling the quickest are the ones that don't need much love after the sale. You know, the homes that are
Yeah.
turnkey, ready to go. And people are more and more today spending less time looking at the beautiful kitchen and more time looking at the mechanics of the house. Am I going to have a cost of an HVAC system or a water heating system 6 months after getting into the home? Those are things that are really raising flags with a lot of the buying public when it comes to real estate. And I'm getting this information from my networking groups with all the realtors in there, by the way. So,
Yeah.
they're
Right on.
letting me know what's going on. And so, we work closely with a lot of realtors to help their clients make decisions on should we replace, should we do this proactively to help add value to the home, help sell quicker than my neighbor's home if it's up for sale at the same time. So yeah, very important to have that consideration.
And if someone is selling like that, you'd obviously, I'm assuming, recommend something. Would you still recommend a high efficiency, or it's more of like a mid efficiency, just something that's, gonna, because I feel like when people are buying a home, they're not asked, they don't really care so much about the efficiency. They just want to know that it's new and it's not going to break and be expensive.
Yeah, no, you hit it on the head. And I definitely have that same conversation with my clients or with the realtors it's their client. I always tell them, look, if you're moving out of here, people are not going to care about, is it a 20 seer, is it a 25 seer, is it inverter? They just want to know how old it is it, again,
Yeah.
am I going to have to replace this thing in 2 years once I move in or not? And so having a newer system with a warranty that can be transferred over to them, those are some of those mission critical moments where, yeah, you should go with an entry level system, mid tier system, have that warranty in place. It'll transfer over. And then the new buyer is going to have peace of mind coming into the house.
Right on. And then as far as building considerations, because you kind of touched on it a little bit, I know the DMV or I imagine some of the homes you're referencing are older and have been like, what is the age of some of the older homes that you guys are seeing in terms of like building year and insulation and things like that?
So this is an older area. There's a lot of aged sections, and then there's like
Okay.
newer sections behind that.
Got
As
it.
you get closer to the city, you're going to find, and by city I mean DC, you're going
Sure.
to find much older homes, and then as you get further, they get progressively newer. And
Gotcha.
typically, this is a unique thing. About every 5 to 10 miles is another band of newness. So
Okay.
you get 5 miles down, you got homes that are about 5 years older. You get five miles further than that, they're 5 years. 5 years newer. They're 5 years newer than that set of homes. So as we keep growing outward, everything's just getting newer and newer. So there you have it. I mean, we've got homes from the 1700s in Alexandria all
Oh,
the
wow.
way to new construction right up the street here. That was just built last year. So.
As a company, do you guys do insulation, or do you work with other contractors that do insulation when you walk into a house and it's like the envelope is just not cutting it for, like, if someone wants to go with a heat pump, right? What are you guys running into?
We will find, especially in the older homes, there's plenty of homes out there that either have like rock wool insulation, which is the very old stuff, or some homes don't have any insulation at all. Now,
Wow.
we as a company don't provide that service, but we are partnered up with plenty of energy efficiency, like home energy companies that do provide that service. So they'll come through, they'll be able to inject insulation into the wall space if there's none there. It's a pretty unintrusive process, actually. I was really surprised to learn where technology is in insulation. Same thing up in the attics. They'll be able to either do, spray foam insulation, blow in fiberglass, whatever have you. They'll even be able to seal up where your receptacles and light switches are on outside walls to prevent air leakage and gaps there. And that's where you can really take a heat pump system and make it not just comfortable, but super efficient.
Yeah, absolutely. No, I was just curious because definitely run into that out here too. Obviously, is when we'll see an attic and someone doesn't have, they've got this much insulation when they should have this much insulation, and it makes a huge difference. Like we did insulation just in one section of our house because we only had an attic in one section, and the office went from feeling drafty. You could touch the ceiling; it was like ice. There was literally no insulation. And after the installation, it's a lot more comfortable. So,
well, and we have some unique tools also that help us with that specific thing you just talked about. So when we have clients that have, an isolated room or a space or like a closet that seems to be really, really cold compared to the rest of the space, we pull out our thermal imagers. I mean, we have thermal image cameras and we have the high-end FLIRs that are really, really accurate. And we're able to locate and identify a lot of problems. I mean, we've had instances where we've installed inverter-driven systems and the home had some adverse reactions. And of course, the client, calls us, hey, ductwork is sweating. The system was just installed. It's got to be an issue. We go out, we do a full analysis. The system's running fine. And then we go ahead and do a thermal image scan. And then we start to find these massive gaps in the home, the exterior structure points of the home that you can't see because of either siding or brick, or it's covered up by drywall on the inside, but there's literally massive gaps. And once we've identified that for the client, we're able to scan it with the thermal imager, snap a picture of it for them, give them a full write-up and report, and then put them in contact with a home energy company that can help to resolve that issue for them. And that's been met to a great deal of success and happiness with our clients because we become a one-stop shop at that point. While no, we're not the next contractor doing the work, we can put you in touch with somebody who's very reputable that we're willing to recommend to you. If we recommend them, we're putting our stamp on them that they're going to be a good contractor for you.
right on.
Yeah.
And then also just kind of switching gears here. We've talked a lot about obviously heat pumps, forced air systems, but you guys also do a lot of boiler work. Is that correct?
Oh yeah, love boilers.
Awesome. And so for people that are watching this, I guess one of the things we get calls about, and I don't know if you guys get this out there a lot, is people that are interested in either adding like radiant floors if they already have an existing boiler. And people are asking obviously about high efficiency versus cast iron. Me personally, I like cast iron. They're reliable. They're obviously not nearly as efficient. So depending on the home and the envelope, natural draft, it's just we don't have problems with them. We're dealing with different there's obviously a lot of design considerations. We still put I have I have two high efficiencies at my house because we have a snow melt and we also have a combi boiler, so I don't have a cast iron. But that being said, I know you guys run into a lot of different stuff out there. What are some of the customer requests that you're getting? What are the systems that you're seeing installed? And then what are some of the issues that you're seeing installed? I know that's like a big question to unpack or a lot of different things, but I just figured I'd put it all out there and let you kind of run with it.
Yeah, no, that's okay. That's okay. So we live in an area where boilers at one point was the main heating system that was here. Now, with the way that home building has gone, and particularly in this region, builders are wanting to do things at a more cost-effective pace. That's contractor term for cheap.
Sure.
And so they, what they've done, they've gone to, central duct systems with forced air where you can move air as opposed to having hot water piping running throughout the house, which typically is going to be in today's world copper, which is very, very expensive. I think that I'm kind of disappointed because hydronic heat is so even and so much more comfortable. You're not moving air, so you're not drying out the air. It's pretty consistent on all levels. Like you don't have the discrepancy of it's so much warmer upstairs versus downstairs. Generally, wherever you've got the hot water running through the radiators, you're going to be warm. But what we come across in our region for those that do have boilers, we find a lot of 50 and 60-year-old boilers that are still rocking and rolling, doing their thing. They're turning on, they're turning off, they're heating the home, but are they safe? And that's where we can go in, do a combustion analysis. We can discern, is this thing really operating at peak safety? It's obviously turning on. Older ones are not that efficient, but there's not huge gains in efficiency with the old atmospherically vented boilers anyway. But, is it going to need a super big cleaning where you have to de-jacket the thing, get in there with the big brushes and get everything cleaned out? That could be a very expensive situation. Cool thing is there's a lot of newer boiler setups where people can save space. We can do high efficiency condensing boilers. Bosch makes a great one. Weil McLean makes a great one. You can mount it on the wall. Navian's another one. You can mount it on the wall, save a tremendous amount of space on your flooring, and the repiping is not too much of an overhaul. We're going to find a lot of cast iron in our region, though, because it is older boiler systems. So you're rarely going to find copper throughout. The other thing that we find a lot of are the vertical radiators. The very, very old, very beautiful, the ornate ones that were hand laid, where they have all the neat design in them and everything. People want to keep those. They want to keep that beautiful old feel, especially in DC. And so there's actually a market for resale on those old stand-up cast iron radiators, which is pretty neat. There's companies out there that will clean them out real good, ensure their quality, make sure that they're going to last another 100 years. So yeah, so those are the things that we come across with boilers.
Right on. And those radiators, they're running at a higher temp, right? Same as baseboard heat, like 180 degrees is what you run through the. Okay. And then are you running in those systems though? I mean, you run high efficiency. You can run a high efficiency through a radiator system, right? It's just about getting the venting out. Is that the issue you're
Correct.
running?
Yeah. That's when you're going to change from an atmospherically vented, just using gravity and heat to carry the post-combustion flue gas out of the house. You're going to direct vent it. So you're going to use Schedule 40 PVC. You're going to run an intake pipe outside. You're going to run an exhaust pipe outside. That does a couple of things. One, it's going to improve the overall efficiency of the system. It also gives it the ability to have a modulating setup where you can run at lower BTUs and lower temperatures to achieve the same purpose. Excuse me. And the condensation as well. It's going to capture that condensation and grab that extra heat, increasing the efficiency. The other benefit is that it improves building performance. So now that you're not burning oxygen from inside the house, you're not potentially putting the house into a negative pressure, bringing in outside air and drafting or anything like that, because you're actually using outside air for combustion. So yeah.
Yeah, and the direct vented appliances too, they're nice because a lot of times you're able to cap off the combustion air, right? Because do you guys put in a lot of combi boilers, or do you do a high efficiency with a sidearm, or do you have a preference?
Yeah, we'll do a few combis, and then sometimes we'll have the standing storage tank that we'll pipe over to it to help heat that up and give the client at least a tank, so that way if if the boiler was ever to have an issue or power was to go out to where it couldn't run, you've at least got a storage tank with 50 or 75 gallons sitting there. Combis I think are still new to the market, new enough that while we are installing them, not nearly to the amount or volume of the standard boilers or the high efficiency boilers.
Right on. And as far as because obviously you see a lot of installs out there, and you guys do service and new installations, and you're doing mostly retrofit, right? No new construction.
Yeah, we try to avoid new construction. We'll work with a few private builders because those are always fun jobs to do. They provide
Like custom homes.
Yeah, custom home setups. Yeah.
Nice. Yeah.
They provide unique challenges that are always fun. It just keeps your brain intrigued with what we're doing. But we try to avoid it more so over because it can become a bit tedious and longer stretches of time to accomplish something. So retrofit is our target, and we have a lot of fun with that too. I look at retrofit as cleaning up other people's messes. I'm sure
Totally.
you've come across plenty of systems you've seen installed where you're like, what did they do? And then you get to go in there and do it the right way, clean it up, prove with science and data that we're actually producing the CFMs and the BTUs that's required for this home and for that client, really meeting their needs and increasing their efficiency overall.
Yeah, absolutely. What are you running into in terms of problems? Like, what do you see some of the biggest mistakes made on some of the installs that you guys are cleaning up? Is it like, like piped wrong, or what are you guys running into?
When it comes to HVAC, a lot of the retrofits that we're doing are from the time of new construction. And so you can see that clearly it was all about the speed of how many jobs can you get done in a day. So it's really cleaning everything up. I mean, the way that the ductwork is actually connected to the evaporator coil or the furnace or the air handler, the sizing of the ductwork. We've seen instances where I guess the installing subcontractor flip-flopped the return and the supply ducting. So you've got really small returns in these oversized supplies that really don't create a good balance for the system. So we've seen everything. I mean, from kinks in copper line sets that were hidden way up in a ceiling, behind the insulation or the rubber techs, gaps in the ductwork connections to the actual equipment itself, things not being sealed up. So you've got a lot of air that's leaking out all over the place. Flue piping that actually somehow passed inspection, but is undersized. So, I mean, we've seen all types of stuff out there. And that's where we actually have a lot of fun, because cleaning up those messes and getting it to where it's precise in the way it should be, that's a good feeling. That's a very good feeling.
Yeah, absolutely. No, and I think that your techs learn a lot about HVAC by doing it too, because when you see why something's not working, and you have to spend, an 8-hour day at the same job fixing it to make sure someone has heat, and it was because it was like a systemic problem, and you fixed it. You learn like, oh, the importance of airflow, in
Yes.
one lesson. So that's great.
Yeah, one of the things that we have learned over the years, that I especially have learned over the years, is that most of the service calls that we end up running, most of the fail points are all install derived. And it's not like it's a thing where the installation happened and within a month or 3 months or 6 months, we're having this problem. I mean, these are like long-term effects that create problems that show themselves down the line. So for example, airflow, there's a chance that it may not immediately show that problem, but then let the temperature get up past 100 degrees and all of a sudden you can't keep up. And it's not because of the system, it's because of the ductwork. So there's we find that, again, systemic issues that present themselves 3, 4, 5 years down the line. So yeah.
Right on. And also, just switching gears, because I understand you have some experience about geothermal. So I'd like to, ask you some questions and pick your brain, because we do get a lot of interest in geothermal. I have my opinions, which I'll share later because I want to hear yours first. But when you're talking to people about geothermal and comparing, let's say let's say they're putting in a new system and they are like, hey, we're considering geothermal or high efficiency heat pump and furnace combo. Or maybe they have, radiant in-floor heating. And so that's why they're considering geothermal. What are the considerations and how do you compare those two? And what are kind of any thoughts you want to share on geothermal and how it works?
Yeah, I mean, look, the idea of geothermal and how it works, the principles of it is really smart. It's a good thing. I think the biggest detractor with geothermal is the initial investment cost. There's a lot of bad information out on the internet that has people thinking that it should cost $1 amount, where really the fixed cost is going to be significantly higher. I've seen estimates online of $30 to $40 or $50,000 initial investment cost, and that's generally not the case. I mean, generally speaking, $30 to $40,000 is what it's going to cost to drill the hole, to run your piping for the actual loop that goes into the earth, and then you've got bring the loop in, you've got the equipment after that. So really, I mean, when I'm talking to my clients about geothermal systems, I try to really understand what their goal is. Do you want efficient, cheap heating and cooling? Is that the target? Do you want to reduce your carbon footprint? Is that the target? How long are you planning on being in the house? For those who are going to only be in their house for 10 years, the investment cost is not worth it. You're not going to get that money back. And I don't see where it's going to add any value to the home either. Not to mention, not every home needs geothermal. I believe that the structures, the physical structures that actually are more so the ones that need geothermal are the ones that are massive structures with a tremendous amount of cubic volume, right? We're not heating and cooling the floor. So square footage is this much. It's the cubic volume. You could have a 5,000 square foot house with 12-foot ceilings, and it's a lot more cubic volume than if it had 8-foot ceilings. So, larger cubic volume, that's where geo can be a good thing, but also longevity in the house. It's still a heat pump system, so it's still going to have fail time and it's still going to have a lifespan. And if at 15 to 18 years in that heat pump fails, you got to replace it, and that just kicks the return of investment can further down the line. So I'm a fan of the idea of geo. I think that if its cost was more effective for the general public, it'd be a smarter idea. But you can actually achieve a lot of that efficiency by going with a dual fuel inverter driven system or an inverter driven heat pump system. I can give you a quick example. I had a client who was an economist for the federal government. So numbers, that's what he does. He calculates things all day long. And he wanted to go geo. He had a 10,000 square foot house, pretty much an average of 10-foot ceilings throughout. And he really, really wanted to go geo. So we sat down and we crunched the numbers. We talked about the investment cost of geo, drilling the hole, running the piping, getting the new equipment set, all the electrical runs, everything that's required. And the investment on that was going to be around $75,000 to $82,000 based on what the drilling company was going to tell us once they started actually putting the hole in the earth. We did the analytics on that, on what the cost benefit would be for him, because he was on propane a lot like I am here at my house. And then we ran the numbers on actually doing a conversion to a dual fuel setup. We took his furnaces from 80% to 97%. We used American standard modulating gas furnaces. We did 20 SEER heat pump systems with that. We converted his water heater to a tankless, which was 96% efficient as well. And when we ran the numbers on that, it looked like we were going to actually achieve a return on that investment at year 11.8. So almost 12 years in on the new equipment, the savings from the reduction of propane consumption was going to pay off the equipment. His all-in investment cost on that job was going to be around $45,000. So almost about half, roughly 40% less, 45% less than the geo investment. I got to speak with that client about a year and a half, 2 years later, and we reduced his propane consumption by 93%. That brought his return on investment up from 11.8 to year 7.9. And so within the warranty period of 10 years, he was able to pay off the equipment from the savings of the propane. So listen, if it's all about efficiency, we can do it another way, and you don't have to spend all the geo money.
It's definitely more of an off-grid product, you would say, just because that's where the cost for heating is more expensive, because you're dealing with oil and propane at that point. So that, improves that break even. No, I'm kind of in the same boat. I know right now there's a 30% tax credit on geothermal, and so that does bring it down. But that's still, if you're talking 80 versus 45, that's still an extra 10, 15 grand. So it does make a difference. But I've for viewers that are watching, I think this is my opinion. I'm curious if you agree or disagree, but I think like they make a lot of sense in places like Canada, or places where it's like, because you're getting like -20, -30, where just most like air source heat pumps, the COP drops at those temps. Whereas geothermal, you're still going to have a COP of like 4.5, 5, 6, even with those super cold outside temps. And so that's where it makes sense, especially if you're off grid, because then you're propane. And so, I mean, I think in those environments, it makes sense. But even then, though, you could, well, I guess no, because you really can't run a heat pump when it's that cold out. You could do dual fuel for sure.
You can do dual fuel, and you would work to a degree, right? Because there are cold climate heat pumps that exist that can operate at -15 degrees. But even with that, it might still be a little bit drafty. So I mean, to your point, those colder temperatures really could benefit from having that kind of a setup. Our market, we just don't get that cold. I mean, we really just our average hover temp, where it just generally kind of hovers over the winter season, is mid to upper 20s. It's not like super cold. It's tolerable. Cold climate heat pumps work really, really well. Inverter driven heat pumps work really, really well in our market. So it's just, there's no need for all that additional investment costs.
Yeah, no, that's kind of what I thought. And it's funny because sometimes when we'll put out a video that's about like, cold climate, heat pumps working in cold climates, and like, that's a myth, blah, blah, blah. And I'll always get someone in the comments that's like, it's -50 at my house. I'm like, listen, if your neighbor's Santa, okay, it might not work. I'm not gonna like, you're okay. You're probably going to be making a fire at that point and running your furnace. Like, so, but for everyone else who doesn't live in the North Pole, they work. So, but people love to bust your chops. That's the comment section on YouTube for you. Thanks for being on the show. This was great. A lot of valuable information for our viewers. Where can people find you if they're in the DMV area? Website?
Yeah, definitely. So in the DMV, we're actually running under 2 different brands right now. So you can find us IAQ Medics on the Virginia side. You can find us at IAQmedics.com. And then Michael Bonsby Heating, Air Conditioning, Plumbing, and Electrical in the Maryland and DC side. And that's at michaelbonsbyhvac.com.
Right on. And you're the founder of IAQ Medics, and you now manage both those branches. Is that correct?
That's correct. Yeah. So founder and owner of IAQ Medics, and now the director of operations for the DMV on a little bit of a larger scale, and incorporated our brother company, Michael Bonsby, HVAC, Plumbing, and Electrical. And it's fun. We got a lot of great technicians, a lot of great admin staff. Our customer service is been nationally recognized for just our support and how we take care of our clients. So, satisfaction, taking care of people in a timely fashion, being responsive, clear cut with everything. That's just the way that we operate. And we've had a great reflection of that on our Google reviews. Check us out.
Right on. Well, Dario, thanks for coming on the show, and everyone at home, thanks for watching. Don't forget to like and subscribe.